Hello everybody. In this video we are going to be looking at the solution to the college prep electromagnetic induction due right now number 2. We have a 500 turn circular loop coil 15.0 centimeters in diameter is initially aligned so that its axis is parallel to the Earth's magnetic field. In 2.77 milliseconds, the coil is flipped so that its axis is perpendicular to the Earth's magnetic field. If the average voltage of 0.166 volts is induced in the coil, what is the magnitude of the Earth's magnetic field at that location? All right, there's a lot to unpack in this problem, so let's take a look and see what we are given here. We are given the number of turns of the coil, which is 500 turns. And we are given the diameter of the coil at 15.0 centimeters. We do have to convert that to meters, so that's going to give me 0.150 meters. Now, in order to find the area, we are going to need the radius of the coil. So I know the radius is half of the diameter. So the radius is going to end up being 0.075 meters. The time it takes to go from parallel to perpendicular, in other words, in time it takes to go and rotate from rotate 90 degrees, is 2.77 milliseconds. We have to convert that to seconds, so it's going to be 2.77 times 10 to the minus third seconds. And that is important because in the beginning of the problem, we are told that the coil is parallel to the Earth's magnetic field. Remember, when the coil is parallel to the magnetic field, the magnetic flux in the coil is going to be 0 because there are no magnetic field lines going through the coil. But then when it is turned perpendicular to the magnetic field, the number of flux lines going through the coil is going to be at its maximum value. So that fact that it's turning 90 degrees is important. We are also told that the induced EMF in the coil is 0.166 volts. And we are being asked to find the magnitude of the magnetic field. So I need to use Faraday's equation for this problem. And I know that, again, remember this symbol right here, which is my Greek letter epsilon. So I know that epsilon is my symbol for the induced EMF, and that reads the same as a voltage. So we can just treat that the same as voltage for our purposes here. And I know that the induced EMF is equal to the negative of the number of turns times the change in the magnetic flux divided by the change in time. And because I know magnetic flux is equal to the area, is equal to the magnitude of the magnetic field plus the area of the coil, I can replace that in the equation for the magnetic flux. I want to solve this equation for the magnetic field. So when I do that, I'm going to end up with B is equal to epsilon times delta T divided by the negative of the number of loops of the coil times the area. Now I'm plugging my known values into that equation. One quick note for the area, I am just putting my formula for the area right into the equation because remember, area of a circle is pi r squared. So I have my pi here, and then I have the radius, and I am squaring that. When I do my calculations, I should get a magnetic field of negative 5.2 times 10 to the minus 5th Tesla.